Okay, so notes 8.5, variation application, or in the book is 2.5. Your objective, you'll find the variation constant and write equations given data points. So they'll give you some information and you can write an equation about it. So here we have direct variation is a multiplication problem. F of x equals k of x, where k is a positive constant. So y varies directly as x. This is what you'll normally see. Inverse variation is going to be division. F of x equals some value k over x, where k is a positive constant and y varies inversely as x. K in both is called a variation constant. One of the things that sometimes that's all you'll be asked for is what is the variation constant? Okay, so the first one, find the variation constant and an equation for a variation for the given situation. I will be looking for three things on this, that you identify what this one means, y varies inversely, and then, so that's the first one. So y varies inversely tells us that this is y equals some value of k over x. That's the first thing I look for. Second thing, substitute in your known values. So y is 12 over k over x. X is 5. Step 3 would be to solve. So times 5 times 5. So I get k equals 60. So there's your solve. I will be looking for this guy. You need to identify. You can't just write it in. You have to show me how you got there. And then your last one is to plug in your k value. So y equals 60 over whatever x is. And that's it. And that's this. So I'll be looking for three things. I'll be looking for you to show me the generic equation. Basically show me that you know what inversely means. Second step is solve for k. And third step is to substitute k in to your step 1. Okay, so let's try another one. Y varies directly. So that means y equals kx. That's the first thing I'll be looking for. Substitute your known values. So 3 equals 33k. And solve, so divide by 33. So I'm going to get k equals 3 over 33, but that nicely reduces down to 1 over 11. So k equals 1 over 11. And then our last step is to substitute. So y equals some x value over 11. And there you go. Okay, so let's do an application problem. Rate of travel, the time t required to drive a fixed distance varies inversely as the speed r. So inversely is going to be the y equals k over x. But notice they didn't use anything there. So we have to identify what y is. Y is time t. It says the time required to drive a distance. The distance is going to be your k value over, and your x value is r. And you guys should recognize this as being the distance equals rate times time divided by rate. So now we have all this, we can plug everything in. So it takes 5 hours, so 5 equals, by the way, yes, this is the first thing I'll be looking for. 5 equals the distance we don't know over the rate of 80 kilometers per hour. So d is equal to, multiply both sides by 80. And we get the distance is 400. 400 what? 400 kilometers. Okay, so there's your d value. So then we plug it back in. So we have t equals 400 over r. Now that got us this far. This is how long will it take to drive the same distance at a speed of 70. So t equals 400 over 70. Let me square this. Important information. Start reducing. And so t equals 40 over 7, which is approximately, actually no approximately, we know exactly how much it is as soon as we do the math. Is 5 5/7 of an hour. So we can claim it to be a little over, a little more than 5.5 hours. But this would be the correct answer. So if you're driving 70 kilometers per hour instead of 80 kilometers an hour, it's going to take you almost an hour longer to drive it. Okay. The next problem, this one here, I'm putting aside for class. We'll do this one together in class. That way you guys can get in there and figure out what's going on. Okay, combined variations. Now they're going to start looking at more than one thing. One varies directly, which means multiply, as the nth power of x. There it is. Y varies directly, so multiplication, is the nth power of x, x to the nth power. Inversely, as the nth power, k over x to the n. Or you might have something like this. Y varies jointly as x and z. So jointly is the same as directly, you're multiplying. Okay, so we only have a couple examples, so I'm going to do one in the video, and then we'll do the other one in class. So this one here, y varies jointly as x and z, and inversely as w. So y equals k times xz over inversely as w. First thing I'll be looking for. So plug in what you know. Y is 3/2. We don't know what k is. X is 2, z is 3, and w is 4. So we have 3 over 2 equals 6k over 4. Now if we do a quick cross multiply, we're going to get 12 equals 12k, divide both sides by 12, and you get k equals 1. You need to know that k value, and we plug the 1 into here, and we get y equals xz over w. Please show your work on this. You can't just go, oh, here, this is the value. Okay, this one here is the one we're going to do in class. But I can from there show you guys what the homework is. There it is, 1 through 37 odd, and then problem number 43. Okay, good luck. Nice short video again.